Hello and welcome to this 5-minute clip looking at an enthalpy exam question set covering definitions, Hess's law, Q equals mc delta T calculations, and some factors affecting delta CH calorimetry. So the first definition question asks you to write an equation including state symbols with a chemical change that represent the standard enthalpy change of formation. Now to do this you need to understand the definition of standard enthalpy change of formation. So therefore this means the equation must have all reactants and products in their standard states, plus the alcohol being formed must be 1 mole in the equation. It needs to be in liquid form obviously, and to work out the number of carbons and hydrogens and oxygens you need to think about the actual elements in the standard states and how they're formed. So therefore carbon is a solid, hydrogen comes from hydrogen gas, oxygen comes from oxygen gas. So you can construct an equation quite easily by using CH2 and O2, so it all adds up to C5H12O, and that gives us a mark. Going on to the next one is a Hess's law question, so therefore what you need to use a Hess cycle of this type. So I'm going to put the equation across the top, and along the bottom I'm going to put the elements in their standard states that make up the compounds in the reactants or the products. And this came from the previous question, so you can see how one section leads into another. First thing to do is to put the arrows pointing upwards towards the compounds. I'm going to ignore the oxygen because it's an uncombined element. And putting in the numbers like that, I can now construct an expression. And before I do that, just actually putting those numbers in is a piece of processing you have to do, so you get a piece of credit for that. Putting in the numbers, you'll notice that I've put in a plus 366 instead of a minus 366. That's because this is the direction in which the minus 366 acts, but obviously I'm travelling in this direction around my Hess cycle, so keep the magnitude but reverse the sign. So putting that into my calculator gives me minus 3320, and that's 2 marks. Going on to the next part, we're looking at a calorimetry experiment, and you've got some data there that a student recorded when they burnt some alcohol J. It was 1.54 grams of alcohol was burnt, 180 grams of water was heated, and the temperature change that was recorded was from 22.8 to 75.3. So there's 3 strands to this answer, and we're going to do each one in turn. So Q equals mc delta T is the mass of the water times the specific heat capacity, C, which is your 4.18, and it's 52.5, so therefore that gives us 39.501 kilojoules. Working out the number of moles of C5H12O is the mass over the MR, which is 1.54 grams over 88 grams per mole, giving us 0.0175. And finally, working out delta CH, we need to do minus Q over the number of moles that were burnt. So that's minus 39.501. Now, you'll see I've introduced a minus sign, but there wasn't one over here. The fact that the temperature has increased must mean we've got an exothermic reaction, so therefore energy is released. So that means you put a minus sign in front of the Q. Now, it's to 3 significant figures, and the calculator gives us minus 2257.2. So you're going to convert that to 3 sig figs by doing minus 2260. So you get credit for the first value for Q, you get credit for the number of moles, and the final 2 marks come from the minus 2260. So now the final part of the question says the calculated value of delta HC from this experiment is different from the value obtained from data books. So apart from heat loss, so ignoring heat loss, and we're assuming that the calculation has been carried out correctly, we need to think about factors that are outside our control. So any 2 from incomplete combustion, water or alcohol evaporation, non-standard conditions or specific heat capacity of the beaker. For example, if the thermometer comes close to the metal of the beaker, or the metal of the container, or the glass of the beaker. These are outside our control. What you mustn't do in this type of question is start introducing random mistakes that could well have the same effect, but the question doesn't mention mistakes, so don't start to introduce the idea of their effects. You won't get credit for it. Okay, so hopefully that's a useful roundup of how this question might be tackled in test conditions. Until next time, thanks for listening and see you soon.